Hello and welcome everyone. Our today's question is remove all occurrences of duplicates in a linked list. So we have given this linked list and we have to remove all occurrences of duplicates. So this is a duplicate sublist, this is a duplicate sublist and this is a duplicate sublist. And we have to return the unique values. So its answer is 23 then 35. So first I will tell you the recursive approach. So we have two cases in the recursive case. So first one is this and second one is this. So in this case we have head value as 23 and head dot next value as 25. So it is not equal. So if it is not equal, this is remaining list will be solved using recursion. So head dot next, so its next pointer will pointing to the answer given by recursion. So just to solve the remaining list, head dot next, and we have to return from the starting. So return from head. This is simple, but what we what if we have this case? So head and head dot next value. If it is equal, we have to remove this same sublist. So we have to check. So we will run a while loop because we don't know the length. So if head dot data or value, if it is equal to head dot next dot data, in this case it is equal, so just reinitialize the next pointer. So head dot next will reinitialize to head dot next dot next. So now it is pointing to this value. So just check whether this 28 is equal to this value. Yes, it is equal. So reinitialize your values. So now it is pointing to null value. After that it is null. So we are accessing the head dot next. So just check, just make sure head dot next is a valid value and not a null value. And we have this list, but remember we also have to delete the first occurrence. So just return your solve function, because there may be a case that after this list we have a big list also. So now we are at here. So this look like this: 28, then 35, then 49, then 49. So head is pointing to 28. We have to delete this 28. So this remaining list we have to return from this remaining list. So just return from the remaining list head dot next. So this remaining list will give us the answer. So it's time for base case. What is the base case? Base case, if our head is null or head dot next is null. So which means our linked list is empty or linked list only has one node. So let's jump into the coding part. So this is the base case. Now just check if this value and next value is equal. So we have to run a while loop. So next value, if it is equal, we have to reinitialize the pointer. So now pointer is reinitialized, and we also have to delete the head node because its value is equal. So head is equal to head dot next. We can write it like this and return from the remaining list. If it is not equal, so head and head dot next value is not equal. So in this case, we have to include the head node and head dot next. We have to return from the remaining list and point to the head dot next node. So after that we have to remove the head node. So it is space complexity. If we include the stack space, so it is order of n. And can we solve this in constant space, because expected space is constant? And the answer is definitely yes. We will solve this question iteratively. So let's erase all of this, and we have this linked list. So in this linked list, we will create a dummy node. Dummy node. So this is the dummy node, and this is the head node. This is a dummy node. We have created the dummy node of value 0, of value anything you can create with -1 or anything. So now head, this dummy node next pointer is pointing to the head node. So that's it. We have created a dummy node, and we will start from this dummy node. We have given current to dummy node head. So current is pointing to this node. So current is pointing to this node, and just check whether this value and this value is equal. So head dot next value and head dot next value is equal. In this case it is not equal. So just move your current to next. So now it is pointing to 23, because 23 we have to include. So just check it. Current dot next and current dot next. If it is equal, so what I am saying, if current dot next value is equal to current dot next value. So if it is equal, just take a value. I am taking temporary value and initializing to current dot next value. So temporary having 28 value. So temporary is pointing to 28, and we have to remove this list. So we have to run a while loop, because we have to remove a sub list. So just write like this: current dot next value, if it is equal to this temporary value. Yes, it is equal to temporary value. So we have to reinitialize the 23 next pointer. So current dot next pointer we have to reinitialize, and we have to write it like this: current dot next. That's it. So current dot next value 28, it is equal to 28. So we have to remove this list. So current dot next is pointing to next. So it is pointing to next, and again check current dot next value 28. We also have to delete this node. So delete this node. So current dot next is pointing to current next. It is pointing to this value. Now our question is, check whether this value and this value is equal. It is not equal. So move your current value to next value. So current value points here. Again check current dot next value 49 is equal to next value 49. In this case it is equal. So temporary value contains 49. Now check current dot next value 49 is equal to temporary value. Yes, it is equal. So reinitialize your pointer. Now current next value 49, it is equal to temporary value. Yes, it is equal. So reinitialize your pointer. Is this value is equal to temporary value? No, it is not. So we will run out this loop. and check current dot next value. So 53 and current dot next value 53. If it is equal, so temporary value contains 53. So just check. This value is equal to 53. Yes, it is equal. So now it is pointing to this value. If this value is equal to 53, yes, it is equal. So now it is pointing to null value. So we have to make sure current dot next value. We are accessing here current dot next value. Just make sure current dot next is equal to not null, and here current dot next and next. We have to make sure current dot next and current dot next is not equal, not equal to null. So we have handled this case, and as you can see we are iterating. So above here we have a while loop. While loop current dot next is not equal to null, and current dot next not equal to null. We have this case and we have else case. So if it is equal, so we will go inside. If it is not equal, so we have to move to next value. So current is equal to current dot next value. So that's it, and at the end we have to return. So we have created this dummy node. So dummy. So we have to return from dummy next. So this list. That's it. Let's jump into the coding part. So just create a new head. Value is 0 and new head dot next is equal to head node, and our current is pointing to the new head. So just check, just make sure value our node is not null and our values equal. If our values equal, then initialize a temporary value and check. If next value is equal to the temporary value, then we have to remove the next node. Else means value is not equal, so just move to the next node. So at the end return the head dot next. So that's all, and we have solved this in constant space. If you like this video, a click on the subscribe button is appreciated, and thank you all for watching this video.